document models, an open source primitive for decentralized operations, is what we'll be presenting to you today. And I'll be diving into how you can start with rapid prototyping and app development with the help of these open source document models. We'll do it with 3 parts: a small introduction to document models, the 5 strengths of document models, and then a development demo so you can follow along what exactly is in the works when you try to create your own. Now, what is document modeling itself? It is actually an existing software architecture and practice with a rather rich history, and we use it to capture any existing best practices or processes that have really been successful in organizations, or in our case, decentralized organizations, to capture them into software, documents, or applications. So some of those documents could be a scope of work document, core unit profile, a project scope, or a legal contract. Now, why do DAOs need such document models or such processes? Well, we need to stop contributors from getting lost in the same mistakes that everybody makes. We need to save the experience and intelligence and skill sets from leaving a DAO when a senior contributor leaves, and we need to embed more clear guidelines and guardrails next to priorities and directions into the software that DAOs are using. Additionally, these document models also help in capturing data in a very structured format, and it helps to measure crucial metrics that eventually can be distilled from those models. Now, to make it a little bit more visual, what could such a model look like? In this case, we're having a smart price proposal generator. So it's a generator that helps you to define a model and helps you to select your favorite client or your preferred client. It helps you to set your hourly rate, your standard formula that you want to sell to the client, and maybe also include some expenses. What you're doing here is you're making use of a smart template with rules that is guiding you through all the necessary steps so that the information is captured correctly and that you're not missing any of the essential information. But additionally, it's also offering you automation and structure, because it helps you to reduce errors and capture and store the data in a structured way. So how do we do that data capturing? We do it with the help of a data model schema. That data model schema is the underlying foundation of such a model, and it details all of the different types that we'll be needing to attach our user interface and to add any other user interactions inside the document model. Now, those data model schemas, why do we use them? Because we noticed in design and software development processes that there is always a big step where things go lost in translation. You might have experienced that you're either the customer or the business consultant or even the programmer, and you felt that the whole team had a different understanding about what exactly was happening or what the intended goal was. And that's where the data model schema comes in. Just like English is our lingua franca at this conference, we're all coming from different countries, but we are making use of English to understand each other. That's the way that document models will help stakeholders to align on the specific intention or the specific end goal that they have in mind. And especially our data model schema helps us to make sure that all of the different types that we need to make our end solution a reality are captured in a schema. Now, how does that happen? It happens through an analysis process where people go through stakeholder requirements, where people look at the problem statement and eventually map out a user's use case scenario and try to capture all of the different types that are needed. So how do these document models then move throughout the DAO? Well, they are being synchronized across all the different nodes that the DAO exists of, or all the different contributors that are collaborating with each other on those documents. And later on in the presentation, I'll give a bit more info about how those native apps that we've been building support the transportation of document models. But first, let's look at the 4 examples in different categories across finance, legal, governance, and people ops of how a document model could be used. So in the case of finance, the real-world assets is one of the use cases that we've recently implemented for Maker and Sky. And here, an arranger or somebody who's keeping track of the T-bills within the Sky ecosystem is making use of a real-world assets portfolio, where in the first type we see different attributions being defined for that real-world asset state, such as the accounts, the fee types, the fixed incomes, and the portfolio that is being used in the document model. Now that is then later on being translated to an application or to an interface that the arranger can actually work with and keep track of those, of that portfolio, of those T-bills. Since everything has been captured in a structured format, we can then later on query all of the data that has been captured in that portfolio easily and translate it to dashboards and graphs. Now, for legal, you might think of a multi-sig participation agreement, where we traditionally know this as a contract, and this contract itself as well can be transformed to a data model that then eventually can be transformed into a document interface where somebody can get an instantaneous overview of the document, maybe the effective start date, what the multi-sig method is, but also the participants management panel where the key identifier of each participant is mentioned or logged, and where you can manage this whole contract and also put a legal wrapper or a legal status around the multi-sig participation agreement. Another one might be a governance proposal. I imagine that some of you might be familiar with it, where in our data model we can find items such as the title of the proposal, when it's created, the different stakeholders, the status, but also the impact and the evaluation metrics that then get translated to an interface where somebody actually makes a proposal and submits it to the DAO with its different estimated phases and the objectives and evaluation metrics that then get posted in a dashboard where the different proposals can be followed up on and can be checked at what stage they are. So the last example is actually the one that we'll be looking at in our development demo, which might be the billing cycle for a person contributing to the DAO, where the state schema contains items such as the Ethereum address of the issuer of the bill, but also the stable coin compensation and a proof of work token compensation that will be used for this specific billing cycle. The proof of work token compensation is a token that within the Powerhouse ecosystem represents an opportunity cost, but can eventually also be used as a part of the reputation for that specific contributor, and eventually for retroactive revenue distribution for the module that the person has been working on. That might look like this, where the specific contributor fills in their ETH address and the different line items that they want to add to their bill. Now, these document models that I've been talking about, why are they so special? They have a specific software architecture where you interact with them through the help of operations. You essentially apply an operation to this document model, such as update the title of my document or my application or software piece, which then gets processed by the reducers and turned into an action that updates the UI of the document and also changes the state of the document itself. Now, what are we actually sending then across the organization when we are synchronizing these documents? We're sending these operations to one another. Very similar to how two nodes are interacting over a shared node, which here is represented by Switchboard, and actually acts as a server. So a user might make use of our Connect app, interacts with the document models, and then synchronizes them with another node across the network. This also allows us to set up peer-to-peer connections, and where we can skip the part of using a server-side node that synchronizes the two other nodes. And this is very similar to the transaction-based design pattern that blockchains make use of. So with our DocSync protocol, we're synchronizing documents across the network with each operation being added to the structure. Since the structure of a document model is append only, it's very clear that this mimics many of the characteristics of a blockchain network. So why do we call our nodes reactors? Because the documents are, they are essentially smashing different operations of different documents into each other to make sure all of the data is synchronized. Then looking at the 5 strengths of document models that you'll get access to if you start making use of this open source primitive is we can do rapid application development because there will be a lot of reusable components that we'll make available, and we also hope to revive model-driven development with the help of code generation. And as shown before, this structured data format that we're making use of is actually perfect for automation and AI readiness. Then we'll apply modern day UX UI practices where we integrate with React and make use of the Flux design pattern. Everything is event based, and this actually saves front-end developers quite a bit of time since they can just focus on the user interaction instead of the state schemas themselves. So there's a UI component library growing where all of the items that we are reusing for the different document models can be looked at, can be reused, and can be updated. And that should give developers the opportunity to move quicker with their intended end goal. So what we mostly see here is that devs get the chance to finally focus on user experience instead of focusing on the state management, while still making use of the business logic and domain knowledge which is captured in that data model schema. Now, what else is there? There are some out-of-the-box Web3 capabilities that come as part of our native apps, and those are, so any contributor of an organization can make use of login with Ethereum, where we attach a decentralized identifier to their Ethereum address, which can hold permissions and credentials. Additionally, each modification or edit that has happened to a document can be seen as a part of a transaction log or a history log of that document, and we can perfectly track version histories or keep track of who changed what at which state. So this essentially offers you a way to make any data that you're capturing in those documents you capture them in a verifiable way. Additionally, you have those operations that you can use as hooks for a permission system, so allowing certain contributors to get access to certain documents or to certain specific type of operations that they might want to execute or are not allowed to execute. What else is there? Since it's an append-only structure, these document model operations that we're making use of, they lend themselves pretty well to blockchain-based storage solutions, but we are very agnostic to it as to which storage solution you as an organization might want to use, and therefore we've tried to decouple the scaling constraints of blockchain currently from the ambitions that you might have as an organization. So we have different storage adapters that allow you to save this append-only structure on your preferred storage layer. Then the social collaboration infrastructure, which might be the most interesting, since I'll be introducing some of the native apps that these document models run on and that we've been building in the past 1.5 years. So there's 4 main apps, Fusion being a transparency dashboard and public collaboration platform, which is currently being used by Maker Sky to show all of the latest states of their DAO. And then we have Connect, which is a navigation, collaboration, and reporting tool for the individual contributor where they can work in private. We have Renown, which is our decentralized identity and reputation hub, where you log in with Ethereum, generate a decentralized identifier, and then get credentials or permissions issued to you, but eventually also will collect or start gathering your reputation as you contribute to DAOs or open organizations. And then there is Switchboard, which often functions as a server side or the open data API interface to capture and interact with all of the data that you've been collecting in your document models. So how would that work? A contributor comes in, sets up a couple of models, and is, for example, creating a project proposal, a to-do list, and an invoice, but they would like to share it with other contributors within the network. And they do that all through Connect, which is our contributor tool. Now, other contributors might come online and they want to get access to those documents, but before that, they will need to register through Renown, our identity and reputation hub. where they then get the necessary credentials to access those documents and receive them on their end, so on their nodes. Now, when all of those documents are eventually finished and they want to publish it towards the public side of the DAO, they might transport it to Fusion, where we have our public transparency dashboard and where the results or the data that is being captured in those document models is being displayed and shown to the broader DAO. There is obviously also the opportunity to set up peer-to-peer connections within your DAO or outside your DAO, and those are only a few of the possibilities that the native app infrastructure is allowing you to implement and to collaborate on. What else do we have in this case? We have opportunity for massive horizontal scalability, where we could make use of just one remote node for storing all of the documents, or start making use of one node per document, depending on how intensely a certain document is being used, or eventually scale up to n amount of nodes and use those for multiple documents or shards of databases. Now, I'll want to give it over to Liberum, who will show us a development demo of how such a document model is created and why it is such an easy and quick tool to run open source decentralized operations on. You want to take it over?